Okay, to solve a radical equation, we have 3 steps. Step 1 is to isolate the square root, the radical sign. So if you look here, here's the wall. The left side, we have a square root of x plus 5, but we also have this other term 1. This 1 is not part of the square root, so we have to move it by subtracting. When we move that 1, now we have the variable, the square root, isolated. On the right side, we cannot subtract x and a negative 1. They're not like terms, so we write them in the correct descending order. So step 1, isolate the root. Step 2, to get rid of the radical sign, we do the inverse operation. The inverse of square root is squaring. If we square the left side, we square the right side. Squares and square roots, because they're operations that are opposite, please excuse, they cancel. That leaves us x plus 5. Back when in Module 3, we are squaring a binomial. Squaring a binomial means to write it twice. And the only way to multiply a binomial times a binomial is to do the FOIL method. If I do FOIL, first would be x times x, which is x squared. Outers would be x times negative 1, which is negative x. Inners would be negative 1 times x, which is negative x. Last would be negative 1 times negative 1, which is positive 1. We know when we do FOIL, we collect like terms. In the middle here, a negative x and a negative x are both negative. We would add them. That gets us negative 2x. So now take a good look at this equation. X plus 5 equals x squared minus 2x plus 1. There is no longer a radical sign. This is no longer a radical equation. So you have to think about everything you've learned. Now that there's no longer a radical sign, what kind of equation is this? That's right, it's got an x squared, it's quadratic. Now you have a decision. Do you want to set it equal to 0 and factor it? Do you want to isolate the square and square root it? Or do you want to use the formula? Rule of thumb. When there's many terms, the easiest way to solve a quadratic is to try to set it equal to 0 and factor it. Because I always want to factor with my leading coefficient being positive, this x squared is positive. I'm going to leave it alone. I'm going to move the x plus 5 over here by doing the opposite of subtracting. So everybody look, here comes my new equation. This is going to cancel. That's going to give me 0 equals. I have x squared minus 2x and minus x is minus 3x. Positive 1 and negative 5 is negative 4. Now, if you don't like the 0 on the left, you can now rewrite it. Put it on the right. Okay, what rule of factoring is going to work here? That's correct, an easy trinomial rule. X squared is x times x. What factors of 4? 1 and 4, 2 and 2. Which factors add to negative 3? Subtract to negative 3. That would be 4 and 1. 4 and 1 will subtract to negative 3. Subtract means the signs are different. The 3 is negative, so the larger 4 gets the negative, the 1 gets a positive. So now you factored, you made 2 linear equations. We can solve each of those by setting them equal to 0. And we get our solutions. X equals negative 1. X equals positive 4. We know that's correct. We should get 2 solutions because we had a quadratic equation we were solving. Here's the catch, ladies and gentlemen. Was the original equation quadratic? If you go back to the original equation, here it is. It's not quadratic. There's no x squared in it at all, which means there's no guarantee both these answers work. The only way to know if these are truly both the correct answer is to do a check. And when you check, you go back to the original. So I'm going to write the original. Square root of x plus 5 plus 1 equals x. Square root of x plus 5 plus 1 equals x. We're going to use substitution. Okay? Substitute means replace. I'm going to replace the x's first with negative 1. So this would be the square root of negative 1 plus 5 plus 1 equals. I'm going to replace x with negative 1. When you do a check, you work the left side till it equals the right side, we hope. If we work the left side, we do what's in the root symbol first. Please do the symbol. So inside we get negative 1 plus 5, which is 4. Square root of 4 plus 1 equals negative 1. We square root 4, which is 2. 2 plus 1, does that equal negative 1? We add 2 plus 1 is 3. 3 does not equal negative 1. If your answer you get for x does not make the equation a balance, does not check, it goes in the garbage. It's useless. We call that extraneous. That cannot be the answer. The answer cannot be negative 1 because it didn't make the original equation balance. All right, we have another answer to check. Let's check 4. So we'll put in 4 plus 5 plus 1 equals 4. We'll do what's inside the root. 4 plus 5 is the square root of 9. Plus 1 equals 4. We'll square root 9. We'll get 3. Plus 1 equals 4. We'll add 4 equals 4. That solution checks, which shows you x equals 4 is the solution. So the moral of the story is real simple. We don't have to check linear equations because we know when we solve them we get one solution. We didn't really check many of our quadratic equations because we know when we get both those answers, they should always check. But now that we changed and we're doing a radical equation, because you're taking that symbol out to solve, there's no guarantee the answers you get are correct until you physically check them. Only one of these answers checked, so we can only say the solution is x equals 4. Okay, see you in the last module.